Today we're going to look at lesson 2.7, which is about inverse functions. So today we're going to verify inverse functions and we're going to find the inverse of a function. So let's talk about the definition of the inverse of a function. It says let f and g be two functions such that f of g of x equals x. So notice that we're dealing with a composition here. So g of x was substituted into the function f of x, and that composition resulted in it equaling x for every x in the domain of g. And the same thing, if I put g of f of x, so that means f of x went into the function for g of x, and I get it to equal x for every x in the domain of f. If both those things happen, we have inverses. The function g is the inverse of the function f and is denoted as f inverse. Okay, so it looks like there's a little -1 for an exponent. Okay, so thus f of f inverse of x equals x, and f inverse of f of x equals x. Okay, so the domain of f is equal to the range of f inverse and vice versa. So let's take a look at an example. We're going to show that each function is the inverse of the other. So remember, in order to do this, we are going to do two different compositions. We want f of g of x and we want g of f of x, and we need to get both of those to equal x. So I am going to do f of g of x first. So that means that the g of x, which is x plus 7 divided by 4, is being substituted into the x for the f of x function. So 4 times x plus 7 all over 4, and then minus 7. So since 4 is being multiplied by the fraction, but the fraction contains us dividing by 4, 4 divided by 4 means that we're just going to be left with x plus 7. We're just left with the numerator. So then when I subtract 7, I see that I get x. And that's what I want. In order for us to have inverses, we should be getting the compositions to equal x. But I do have to verify that that's happening the other way as well. So I want g of f of x. So I'm going to plug 4x minus 7 into the x in the g of x function. So we'll have 4x minus 7 plus 7, and we're going to divide that whole thing by 4. Well, the 7s are going to simplify, so that gives us 4x over 4, and that will simplify to x. So we just verified and showed that in either one of those compositions, we were getting an x. So that means that we have inverses. Okay, we're going to find f of g of x and g of f of x, and we're going to determine whether each pair are inverses. So in the last problem, I told you that they were, and we were verifying. Now I'm giving you two functions, and we are going to determine whether or not they are inverses. So we'll start with the f of g of x. So remember, that means that the x plus 3 divided by 7 is going to go into the x in the f of x function. So we will have 3 times x plus 3 divided by 7, and then we will subtract 7. Well, the 3 and the 7 are not going to divide, so I'm going to multiply 3. If I think of it as like 3 over 1, I'm going to distribute that to everything in the numerator. So we'll have 3x plus 9 all over 7, and then we're subtracting 7. So the fact is that this 7 right here, I can really think of that as 49 over 7, because 49 divided by 7 is 7. So they're equivalent. And so because then I can technically have the same fraction or the same denominator of a fraction, I can then think of this as 3x plus 9 minus 49 in the numerator all over 7. Well, if I combine like terms, we're going to have 3x minus 40 over 7. There's no way that I can simplify that down any further. Because I didn't get x, I'm not going to have inverses. They do want us to show both ways, though. So even though we already know that they're not going to be inverses, let's just See, because we could potentially get x for this g of f of x composition, but they both have to equal x in order for us to get inverses. So if I plug in this 3x minus 7 into the x and the g of x, we would have 3x minus 7 plus 3 all over 7. And that would give us 3x minus 4 in the numerator all over 7. I can't simplify that down any further. Once again, we need both of them to equal x. So this case, f and g are not inverses. Okay, so pause the video and see if you can do your compositions going in both directions to see whether or not we have inverses. So in this case, we actually did. So remember, if I do f of g of x, I plugged the x cubed plus 4 into the x underneath that cubed root. So the 4's were able to cancel. Taking the cubed root of a cubed gave us x. Then I wanted to take the cubed root of x minus 4 and substitute that into the x and the g of x. So if I cubed a cubed root, that leaves you just with what was underneath the radical, which was x minus 4. I still had to add 4, and that gave me x. So in this case, I did have inverses. All right, now let's talk about how we find inverses of a function. So if I give you one function, we're going to find its inverse. So the equation for the inverse of a function f can be found as follows. First thing we're going to do is we're going to replace f of x with the letter y in the equation for our function f of x. We will then switch the x and the y around in the equation. We will then solve that equation for y. It says if this equation does not define y as a function of x, the function f does not have an inverse, and this procedure ends. If the equation does define y as a function of x, the function f has an inverse function. So remember, for y to be a function of x means that I can only have, when I plug in a value for x, I only get one answer for y. So that means that we wouldn't want to end up solving for y and getting something like y equals plus or minus the square root of x. Okay, I would need to have for every x value exactly one y value. And if f has an inverse function, we are going to then replace y in step number 3 with the f inverse of x. And then we can verify by always showing that the composition going in both directions equal x. So if you're ever unsure of, hey, is this really going to be my answer? Doing those compositions will verify, yes, if you get both of those to equal x, you know that you did it correctly. If they don't both equal x, well, then you know that you made an error somewhere. All right, so we are going to find the inverse for f of x equals 2x plus 7. So like the direction said, I'm replacing f of x with y. That's step number 1. Step number 2, I'm going to switch the x and the y around. So now this becomes x equals 2y plus 7. I'm going to resolve for y. So that means I'm going to subtract the 7. Now we have x minus 7 equals 2y, and then I'm going to divide by 2. So we get y to equal x minus 7 all over 2. Remember, we're trying to determine if I have a function here. So is y a function of x? Well, if I plug in a number for x, I'm only going to get one answer for y. So this one checks out. I do have an inverse function. So that means that my f inverse is x minus 7 divided by 2. This would be my inverse. Okay, and one more time, I could then go and verify by doing the composition. So let's do that really quick. So if I want f of f inverse of x, remember that means I'm taking my fraction that I just got, substituting it into the x in the original f of x function. Notice that the 2's will cancel. That gives you x minus 7 plus 7, and that gives you x. So that checks out. And then if I do it the other way, so f inverse of f of x, then that means we would have 2x plus 7 going in for the x in my fraction. The 7's cancel. We have 2x divided by 2, so that gives us x. So once again, just checks that we have a true inverse here. Okay, same idea. We want to find the inverse for f of x equals 4x cubed minus 1. So once again, the first step is I'm going to replace f of x with the y. I'm then going to replace or switch the x and the y around. And now I'm going to resolve for y. So I'm going to add 1. So x plus 1 now equals 4 times y cubed. I have to divide by 4 first in order to get that cube term by itself. And now how do I get rid of a cube? Well, I'm going to take the cubed root. And if I do it to the left, I'm going to do it to the right. Okay, so when I'm taking the cubed roots, I'm going to have, I will have a inverse, okay? Because if I plug in any number for x, I'm going to just get one answer for y. So that means that f inverse of x is going to be the cubed root of x plus 1 all over 4. Okay, and then once again, I could verify this by doing the compositions on either side. I'm not going to do that this time, but it is definitely something that you could do to double check if you are unsure. Okay, then let's look for an inverse here. F of x equals 3 over x minus 1. So we'll change that to y equals 3 over x minus 1. I'm going to switch the x and the y around. Now I want to start solving for y. So I'm going to add 1. That gives me x plus 1 equals 3 divided by y. I need to then get rid of this fraction. So I'm going to multiply both sides by y. So y being multiplied by x plus 1 now equals 3. I am not going to distribute the y because I want to get y by itself. Now on the left, since y is being multiplied by that quantity x plus 3, well, now I can divide by that quantity. So that's why we get y to equal 3 all over x plus 1. Okay, this will be a function because once again, if I plug in a value for x, I will get exactly one value for y. So we have f inverse of x to equal 3 all over x plus 1. Okay, so go ahead, pause the video, see if you can find the inverse for f of x equals x minus 1 quantity cubed. Okay, switch the f of x with the y, switch the x and the y around. Right away, I wanted to get rid of that cube, so I took the cubed roots. Then I just had to add the 1, and that was my inverse function. So cubed root of x plus 1. So that's us verifying inverse functions and then finding the inverse of a function.